Hello, my name's Dave Davies. I'm a silage researcher with 25 years experience, and today I want to take you through silage additive articles as they appear in the farming press and how you can read them to gain more information from what you're being told. And my aim is to show you how to decipher the important points on additive literature, be that silage additive brochures or articles in the farming press. And I'm going to use as an example some articles that have been in the farming press in spring 2020 and really show you how to interrogate and find out more in that information that is being provided to you. So this is the article that I'm going to be using, and the first thing I want us to focus on is actually this word at the top, advertorial. That actually means that the company placing this piece in the farming press has paid for it. So the magazine has very little say on what they put in it. And it actually looks like a piece of research. But actually, when we focus in, we might find out more information. So the second thing I want to look at is this piece at the bottom. And because it's blown up so much, you can't see it. But basically, it says Deploy et al. 2018. And how can we look at that original piece of work that's been published? And what we do is we go to Google. We type in the word scholar, and the first thing that comes up is Google Scholar. We click on Google Scholar, then we put in Deploy et al. 2018 and silage, so that we just pick out the silage articles. And what we find when we do this with this particular article is that nothing comes up. These are not relevant to that particular field of silage, and they're not the publication being put forward. And further investigation shows that this article was not published, so the correct way that should have been referred to was Deploy et al. Unpublished, because it has not been scientifically interrogated by researchers in the field and published in a scientific journal. Another fact that Google Scholar is useful for, though, is actually we can put in particular species of bacteria and the strains that are being used by the inoculant company. So this particular article is about Lactobacillus hilgardii CNCM1 4785. And what we can see then is that we can see the articles that are in the public domain that have been published. The first two are published by the European Food Standards Agency, and you can click on the documents here and look at their views. You can look at the trials that have been done, particular dry matters, etc. If you want more detailed information, that you can actually click on scientific papers done by respected scientists in the silage world, and you again can click on these. Some you may not have access to, but often you can look at the abstract at the front of those articles for free. Now, if we move on, the second thing I want to look at is this particular graph and the number of days after opening. And what this actually means is this is a scientific way of assessing silage aerobic spoilage. And what we do in the science world is that we mix that silage up well in air, we pack it very loosely into a container, and we measure the time it takes for the temperature to rise within that particular pot of silage. So it's not like opening your silage clamp with your clamp face and your good clamp management. It's like more the mixer after it's been through a mixer wagon and how we monitor the temperature rise. So basically, we're speeding up that aerobic spoilage process. So in terms of assessing this data and what it means for your silage clamp face, it's an overestimation of the speed of aerobic spoilage. And your clamp management will control that much better than this trial work does. So it's a mistake by the scientists to use this, and then the additive companies to be able to use this to say how stable that silage is. If we move on further, we can see that they're quoting extensively proven Lactobacillus buchneri IMB 40788. And that is the basis of many of the products that this particular company has been using over the years. And if we again refer back to the graph, we can see that that buchneri was actually more aerobically unstable than no treatment in this particular study that they are quoting. Yet they've had this on the market as their be-all and end-all for improving aerobic stability for the last 20, 25 years. So, we need to question this. That's what they were doing with their traditional range of products. This was the untreated, and this is what they're claiming for their new product. So now I'm going to focus a little bit more on the writing, and what we have here highlighted is energy loss of 110 megajoules per ton of dry matter. This is equivalent to a loss of 0.11 megajoules per kilogram of dry matter due to heating silage. And I actually accept that value. I actually think it's an underestimate of the energy that we lose from silage when it's heating. The question is when it's heating and how much of your silage is heating. And in this advertorial, there is then a claim that a clamp of 1,000 tonnes at 30% dry matter can add up to 6,000 litres. And again, the sums that have been used, that would be correct if your silage is 30% dry matter and the whole of your 1,000 tonnes was heating to the levels that they're claiming. The problem is you need to assess your silage clamp. Is it all heating to that much? Are you losing that much energy from the whole of your silage? And many silage clamps, it's small regions within that clamp. And if you assess your clamp properly, you can look at those regions and you can think about why they are heating. So hopefully, with the information I've given you in this short video, will help you to interrogate the literature presented to you, whether that be in face-to-face communication with an additive sales representative, whether it's in the farming press or whether it's the brochures that they send to you through the post or that you pick up. And you need to question the whole time, all the data that's in front of you, and question how that fits in with your silage problems, your silage issues, and your silage management. And I just want to reiterate, the main factors affecting silage aerobic stability at feed out is your silage management. Compaction during filling, so even layers, making sure it's well compacted. Sealing properly, making sure that all around the edge of that clamp is well sealed, that no oxygen or air can penetrate that clamp, and that the CO2 that's produced during that fermentation is trapped in that. And then feeding out properly, making sure that you feed out with a sharp cutting implement to maintain a solid face and that you feed out rapidly across that clamp face. And all of those things will help to improve your silage aerobic stability, reduce those losses. But please, use the information I've provided to interrogate this silage literature that's facing you day in, day out. I'd like to now say goodbye. I hope that the information in this short video has been useful for you, and please comment if you have questions. Goodbye.